Good morning. We are going to be doing the first section of Chapter 9, solving quadratic equations by taking square roots. Along with that, we're going to learn some vocabulary and review some of the rules that we have for simplifying radicals. Okay, so Roman numeral 1, what are the basics for radicals? The basics for radicals. Okay, so number 1. Let's start with body parts. So square root 10. Okay, so the bar that's around the 10 is the radical sign. The inside of the radical, the 10, is called the radicand. And the invisible 2, or other number that isn't invisible, right, which will occur right there, a very small number, is the index or the root of the radical. And it can be 2, 3, 4, any whole number, but the default index, if there's nothing there, is a 2, and that would be called a square root. So special names. If there's a little 2, we call it a square root. If there is a little 3, we call it a cube root. And anything else, like a little 4, you just use the ordinal form. So this would be 4th root. After that would be 5th root, 6th root, 7th root, and so on. Okay, item number 2, a quick review of the quadratic equation, not to be confused with the quadratic formula. The quadratic equation is ax squared plus bx plus c equals 0, and a can't be 0. So basically a quadratic has an x to the power of 2, and then it may or may not have a b or a c, but it has to have an x to the power of 2. Okay, term number 3, parabola. A parabola is the graph of a quadratic. And parabolas either open up like a horseshoe opening up, or they open down for what we're going to be doing. But the name of the shape of the graph is a parabola. The name of the equation that creates it is a quadratic. Okay, number 4. There's sometimes a confusion between finding roots versus finding a square root. So, for example, in your worksheet, they're going to ask you for the roots of the number 4. So the roots of the number 4 are numbers that multiply to give you 4. So since negative 2 times negative 2 equals 4, negative 2 is considered a root. And positive 2 times positive 2 also equals to 4. So the roots of 4 are plus and minus 2. Now, this is different than if you're trying to find the square root of 4. When you find a square root, you prime factor the number, which in this case is 2 times 2, and then 2 2's, 1 comes out. 2 is the square root of 4. So this is roots, this is square roots. Okay, number 5. It's important to remember that a radical is a grouping symbol. And in order of operations, when we do grouping symbols, we simplify them from the inside to the outside. It's also the first item that we deal with when doing PEMDAS, or order of operations. So if you have a 3 radical 2, just like when you have a 3 in front of a parentheses, a 3 in front of a radical 2 is being multiplied. And again, it's just like a 3 in front of an x plus 2. We know from experience that is 3 times x plus 2. This is the same thing. It means multiply. Okay, Roman numeral 2. Passing on to the next topic, we're going to practice simplifying radicals, and we've actually done this a little bit before, but now we're going to go more in depth on it. So simplifying radicals. Here's an example. The radical, let's see, 5 radical 9. Okay, so what are the steps? Step 1 is you're going to prime factor the radicand, which is the part under the radical bar. So prime factor the radicand. So coming over to our example, 9 is 3 times 3. That is prime factored. Okay, number 2. If it is a square root, which this is because there's no number there, that means there's an invisible 2. So if it is a square root, for every 2 factors, 1 comes out. Okay, so I have 2 3s. 1 is going to come out to the front where it gets multiplied by whatever is at the front of the expression. The third step when simplifying is you're going to multiply the radicand and the scalar. So if you have factors strung together, you're going to multiply them out. Now in this example, the radical goes away. You can't have an empty radical. So since there's nothing left, it's now gone. And we just multiply 3 times 5 together, which is 15. All right, let's do another example. We're going to simplify negative square root of 150. So your first step is to prime factor the radicand. So 150 is 15 times 10. So 3 times 5 gives us the 15. 2 times 5 gives us a 10. And then this negative in front, remember there's just an invisible 1 out there. You can't have a negative without a 1 attached. All right, so we are prime factored. So number 2, for every 2 factors, 1 comes out. So I have 2 5s. 1 comes out to the front where it gets multiplied by the negative 1. So your last step is to multiply the scalar. So 5 times negative 1 is negative 5. And multiply the radicand. 3 times 2 is 6. And that is completely simplified. All right, moving on. Roman numeral 3. Actually, not Roman numeral 3. Example 3. Example 3. Given the expression b squared minus 4ac, we're going to let a be a 1, b be a negative 2, and c be a negative 3. And your instructions are to evaluate the expression. Of course, evaluate means get a value or get a number. So what you're going to do is substitute these in using your parentheses liberally. So I've got a negative 2 for b, so put negative 2 in parentheses squared, minus 4 times a, which is 1, times c, which is negative 3. And then you're going to simplify it. Now to remind you, when you simplify, grouping symbols come first, which is easy because this whole thing is inside a grouping symbol. Then comes any exponents. Those need to be multiplied out. And then you will multiply or divide from left to right. And then last, you're going to add or subtract from left to right. Now at this point, if you have not already simplified the radical, you want to do that. Simplify the radical or whatever's left that needs to be simplified. All right, so following these steps, we're going to do the exponent first. So negative 2 times negative 2 is a positive 4. And I'm just going to recopy the rest. So that's our exponent. Now we're going to multiply or divide from left to right. So I'm going to multiply negative 4 times 1 times negative 3. And we're going to go left to right. For right now, the 4 just gets carried down. So negative 4 times 1 is negative 4. Keep going to the right. Negative 4 times negative 3 is positive 12, and we're done multiplying. Now step 4, add or subtract. 4 plus 12 is 16. All right, this is where we're going to simplify the radical. So factor 16, and if it's a perfect square, you don't have to prime factor. 16 is a perfect square. 4 times 4 is 16, so 2 4s, 1 comes out. That is your answer. So we did exponent, multiply, add, subtract, and then simplify the radical. All right, example 4. There's going to be a set of questions where the directions will say, evaluate with a calculator. And I believe on your worksheet it says round to thousandths, which means to 3 decimal places. And then they're going to give you an expression that's got a plus minus in it. 3 plus minus 4 radical 2 all over 5. Okay, so the way you evaluate something with a plus minus is you start by splitting it, 1 for the plus and 1 for the minus. So over here we have 3 plus 4 radical 2 over 5. Over here we have 3 minus 4 radical 2 over 5. All right, so at this point, you pretty much have to figure out your own calculator because each calculator is slightly different. If you have a left-right calculator or a calculator with parentheses, you can input the top part. There we go. You can input the top part all one piece. It's kind of hard to see, but 3 plus 4 square root of 2. If you can input that in that order, then you can just push enter and divide it by 5, and you have your answer, which is 1.73137. If we round to the thousandths, it goes tenths, hundredths, thousandths. The thousandths is the third place, so tenths, hundredths, thousandths. 3 rounds the 1 to stay a 1. So our rounded answer is 1.731. That's to the thousandths. Now, if you have a scientific calculator that doesn't let you enter the whole top at one time, then you have to do it in pieces. So to do it in pieces, you want to start with the square root of 2. So you might have to say 2 square root. You might say square root 2. You got to figure that out. You should get 1.41. So square root 2 times a negative 4, enter, plus a 3, enter, divided by 5, enter. And you get negative 0.53137. Tenths, hundredths, thousandths. The 3 rounds the 1 to stay a 1, and it rounds to negative 0.531. So you need to play around with your calculator until you can get the right answer, and then try to use the same calculator on all of your assignments. Okay, example 5. All right, sometimes they're going to specify that you need an exact answer. So exact answer means no rounded decimals, because the minute you round, you now have error and it's not exact. So these two are not exact. An exact answer will have a radical in it, possibly. It will have whole numbers in it. It will have fractions in it. What it won't have in it is decimals. And to do an exact number, you should not need a calculator. If you have to use a calculator to calculate a radical, you are no longer exact. So here is an example. We're going to simplify an expression, and we're going to produce an exact answer. And our example is 4 square root 5 over 2. So to simplify this answer, you have a 4 out front and a 2 out on the bottom. You can only cancel outside numbers with outside numbers. So this is a little bit like 4 halves radical 5. 4 divided by 2 is 2. And 2 times radical 5 is 2 radical 5. So outside number and outside number are the ones you can simplify. You cannot do anything with the 5 and the 2. All right, so those are going to be some simplifying problems on the homework. So let's go on to Roman numeral 3. This is kind of the culmination here. Roman numeral 3, we're going to do solving by doing something called taking square roots. Taking square roots. Okay, so when will we actually use this? We'll do taking square roots if the expression is not factorable, and if the expression has no b term, which means no x term. It's got an x squared, but not a single x term. So example 1 of one that we can solve by taking square roots is 3x squared minus 48 equals 0. You'll notice there's no b term. All right, so here's your steps. Number 1, you're going to isolate the x squared term on one side. Number 2, you're going to eliminate the scalar with a reciprocal, which is, we've done this a lot. And then step 3, you're going to square root both sides. And this will create a split into 2 different answers. Okay, so let's do that on here. Step 1, isolate the x squared term. So I'm going to add 48 over to the right and get my 3x squared by itself. So 3x squared equals 48. Okay, step 2, eliminate the scalar, the 3, with its reciprocal. So we're going to multiply by 1 over 3 on both sides. That gives you x squared equals 16. Okay, step 3, square root both sides. Square root the left, square root the right. Here is the split. You have 2 x's, one comes out. One of them is a positive x, one of them is a negative x. And we already established from a previous problem, 16 is 4 times 4, so 2 4s, one comes out. So we get x equals 4 and negative x equals 4. So of course we're going to multiply or divide by a negative 1. And that gives us x equals negative 4. Now the reason for the split is that there's 2 ways we can get an x squared. A negative x times a negative x will give you an x squared. But a positive x times a positive x will also give you an x squared. And we don't know which one it is, so we have to split it into a positive option and a negative option. In this case, if we had to describe what kind of solutions that we got, we have 2 real solutions. 2 real solutions. All right, let's do another example of solving by taking square roots. This is example 2, which is 2x squared plus 6 equals 0. So step 1, isolate the x squared term. So I'm going to subtract 6 over to the right. So I get 2x squared equals negative 6. Step 2, eliminate the scalar with the reciprocal. I want to eliminate the 2, so I multiply both sides by a half. That gives me x squared equals negative 6 divided by 2, which is negative 3. All right, step 3, square root both sides. All right, we square rooted both sides. This immediately causes a split. I get a positive x equals the square root of negative 3, and a negative x equals the square root of a negative 3. Now, if there is a negative under the radical, it means that we have no real solutions. And this one's the same because you can't cancel the outside negative with the inside negative. So in both cases, there is a negative trapped under the radical bar. So for this one, because there's a negative under the radical, the solution is what we call undefined, or UD, because it is not a real solution and we solve over the reals. All right, last one, example 3. You've got 2x squared plus 5 equals 5. Okay, so first step, isolate the x squared. So subtract 5. That gives us 2x squared equals 0. Step 2, eliminate the scalar with the reciprocal. So multiply both sides by 1 over 2. So now the x squared is alone, and 0 times a half is 0. Okay, step 3, square root both sides. This immediately causes a split for the x into positive x equals, and square root of 0 is just 0. So positive x equals 0, negative x equals 0. So one of my answers is x equals 0. On the other side, to get the negative off the x, we multiply or divide by a negative 1. And 0 divided by anything is just 0. So we only have one solution. You only list it once. So the solution is 0. 0 is real. So if we had to describe it, we have one real solution. All right, that is the end of the notes. Have a good afternoon.